Our today's topic is Units and Measurement, Class 11th. This chapter is divided into two major parts, Units and Measurement. In this video, we will talk about units only. So there are three types of units, fundamental, derived and supplementary. So fundamental units which do not require any other units to define themselves. This means that in fundamental units, all those units are there who are full in themselves. For example, length. The unit of length is meter. These are all the physical quantities. There are only 7 physical quantities which are fundamental. Length, symbol meter, mass, symbol kilogram, small t is for time, symbol seconds, capital T is for Kelvin or temperature, luminous intensity, candela, mole, which is used in chemistry mainly, and its symbol is MOL. The second unit is derived unit. Units which require other units to define themselves are called derived units. All the other units come in this category, which are not in the fundamental units. For example, let's take speed. The formula of speed is distance upon time. Distance we know is the length and time we know is small t, which we used in the fundamental units. Hence, speed is a derived unit. Next units are supplementary units. These units are radian and steradian. There are only 2 units in this category. Radian is used to measure angles which are plane angles, and steradian is used to measure solid angles. This type of angle is measured in radian. This type of angle which are made in a solid figure is known as steradian angles. Now, the most important topic of this chapter comes in this video, which is dimension. I hope you remember the dimensions which I used in the fundamental units. For your convenience, I have written it here. So, the physical quantity PQ which I have written and symbol SY means the SI unit of these physical quantities. So we are going to use length, mass, time, temperature, luminous intensity and mole to make and derive the units of the derived units. It might be confusing, but derive the equation of derived units which we studied a little ago. Mostly we are going to use length, mass and time. Therefore, we don't use small t for time, we use capital T for it. And when we want to use temperature, we use K. So let us take a derived quantity, let's say it be speed. So we are going to find the dimension of speed. So the step 1 is to find the formula of speed, which is speed is equals to distance upon time. Now we know that distance is equals to length, so we are taking the physical quantity L, and time is equals to t, so we are using the physical quantity t. Now the second step is to put these L and T in the formula. So speed is equals to L upon T. Now we can see that L upon T can also be written as L to the power 1, T to the power minus 1. Use the bracket carefully. These bracket means dimensions of the derived quantity. Let us take another example. Now the formula of density, which is mass upon volume. So we use mass is equals to m and volume is equals to L into L into L, which is L cube. Now we can see that density is equals to m upon L to the power 3, which means m L to the power minus 3. From dimension, there are 4 types of questions which are generally asked in school. These 4 types are to find dimension, which are the direct questions. Second is to find the power of an unknown quantity. The third question is to check whether or not the dimension of a given quantity is correct. Fourth question is to convert into different units using dimensions. So the first type of question we have already discussed, but we will take it once again to understand how to find dimensions. Let us find the dimension of force. The formula of force is mass into acceleration according to the second law of Newton. So we know that mass is equals to m, and the formula of acceleration is velocity upon time. The velocity's formula is distance upon time. So the dimensions come out from there is Lt minus 1, which is similar to speed. And when we put the dimension of velocity in the acceleration's formula, the dimension of acceleration comes out to be Lt minus 2. So now we will put these in the formula of force. So the dimension of force comes out to be mLt minus 2. This is a very important dimension, so it's better to learn it. Before jumping to the next type of question, we have to know the meaning of principle of homogeneity. In simple language, we can say that the principle of homogeneity states that like adds or subtracts to like. This principle will get more clear if we will do the question from the second type of problem. So our question says that we have to find the dimension of the given A, B, C, D, where V is equals to velocity and T is equals to time. So let this be the equation. To find this, we will apply the principle of homogeneity. We know according to the principle of homogeneity, like adds like. So the dimension of V or velocity is equal to the dimension of A, because A is added to B upon Ct plus dt and is equals to the dimension of V. Therefore, the dimension of V is equals to A. Now, let us look for BC upon T. So the dimension of B upon C comes out to be Lt minus 2. Now we will find the dimension of dt. So this is how we will solve this type of question. The next 2 type of questions we will do in the next episode of this chapter. Thanks for watching.